Okay, ladies and gentlemen, hello and welcome back once again to the briefing room. My name is Eric Cavanaugh. I will be your host today for this next episode of the briefing room. We've been on quite a rollout here. I'm actually on the road today out at the Oracle Open World Conference, so a lot of amazing stuff happening there. And of course, the buzzword of the conference is big data. Yes, indeed, we're hearing all about it from just about every corner of the universe. And it is fascinating stuff. There's no doubt about that. But it's going to be interesting to see how things pan out because, let's face it, it's a widely used term, and I'm really curious to know what exactly is going to pan out over the next few years. But let me go ahead and start moving some of these slides. So there's a slide about yours truly and enough about me. The mission of the briefing room, as many of you now know, is to essentially reveal the characteristics of enterprise software. So what we do is we have a very unconventional format. What we'll do is we'll take industry analysts and pair them with innovative vendors, and we have a live analyst briefing. So the veteran analysts and the vendors do not coordinate before the show, and that's by design because what we're trying to do is reveal that natural kind of occurrence, that natural kind of conversation that happens when you have a live analyst briefing. Of course, we do it in front of a virtual studio audience, so all of you out there get to listen to what's going on and participate. So please don't be shy. Feel free to ask some questions. So we cover a different topic every month. The topic this month is database. Amazing things happening in the database realm, obviously. There are a lot of different things going on out there. A lot of NoSQL, which of course stands for not only SQL. There's also, of course, new SQL, and I think all of you out there know what SQL stands for, Structured Query Language. It's interesting. It really seems to be doing very well these days insofar as the amount of investment in SQL and in NoSQL and new SQL technologies. So a lot of stuff happening out there. And the vendor for today has been around for a while. So the interesting thing is that MarkLogic is not a new company. There are a lot of new companies that are focused on NoSQL and doing some very interesting things, a lot of them out here in the Valley, Silicon Valley, where I am at the moment. But let's talk about database for a quick second here. The database revolution, and we have a website called databaserevolution.com where you can go and get access to some webcasts we did earlier this year that really looked into understanding what is happening in the database realm. Of course, for many years now, relational has been the titan of the industry. So, of course, Oracle, IBM, Microsoft, lots of companies have relational databases, but the relational model is not the only way to store data. Obviously, there have been object databases for many years now. There are all kinds of databases, algebraic, graph databases, lots of different ways that you can store data, and it's horses for courses, as some people would say. In other words, there are different use cases, and you need to really understand what your business needs, what you're using your database for, and how you're using it before you decide on which database to run with. And relational is not going away, despite the fact that all these new types are coming out and they have amazing kinds of functionality. But again, it's just for very specific use cases. Relational, I would tend to think, is never going to go away. But the question is, again, which kind of database do you use in which circumstance? And MarkLogic is a very, very interesting company. So here's a slide about Neil Raden. He is a veteran analyst. Neil has been around for quite a long time. I'm sure he'd be happy to share some stories with you. 30 years of experience in the industry, and he's actually built systems, folks. So he understands how the stuff works when rubber meets road. And let's face it, that is not a small part of the equation. So MarkLogic, it's been around about 11 years. It is a schema-agnostic, enterprise-grade, NoSQL database. So a lot of interesting things happening there in MarkLogic, and we're going to learn about how it works and what it does and what their strengths are. So here is a slide about Steve Guttman, also an industry veteran. I just found out on the pre-call that, boy, he's been around. He worked at Adobe, he worked at Microsoft, he worked at Autodesk. So one of the nice things about working at different software companies is that you get to see the different kinds of cultures, and let's face it, the culture of a company really drives what comes out of that engine. And cultures are very, very important in terms of how companies work. So when you get to see different kinds of corporate culture over the course of your career, you get a lot of experience, and you can kind of figure out, okay, this is how this particular company works, and then if there's a good fit, obviously you stay and you do good things and you can actually get stuff done. So, you know, software obviously is not like other industries, but it is very much like other industries in that culture drives what you do and where you go. So with that, I'm going to hand the keys over to Steve Guttman of MarkLogic, and the floor is yours.
Great. Well, thank you very much, Eric. I am actually joined here by Jason Hunter, who actually I'm not sure what your current title is, Master of Space and Time. That's what I do. Chief Architect. Very good. So here to talk about MarkLogic, and all right, we'll talk a little bit about it's kind of a pastiche about big data, the architecture,
line unmuted,
the application itself, some of our customers and what they're doing, and we'll sort of wind up and talk about some of the enterprise characteristics of MarkLogic. So MarkLogic is a NoSQL database. NoSQL stands for a whole bunch of different technologies, and I'll kind of explain how we're different. And MarkLogic has the scale, speed, and flexibility needed to build enterprise-critical applications that combine, and this is important, structured, semi-structured, and unstructured information from really virtually any kind of data source. And it combines the best qualities of a search engine and a document-centric data store with enterprise features, enterprise-grade reliability. So we're not a household name yet, but we actually have over 350 paying customers, many of whom are household names and are listed here. We're actually one of the biggest big data companies in terms of both customers and revenues. And the applications our customers are building are, in general, I think, pretty remarkable. And I'll talk about a few of those customers and applications in a moment. But first, let me set the stage. So as Eric mentioned, MarkLogic was started back in 2001, back in the dark ages. And around 10 or 12 years ago, companies were in the process of moving rich client-server applications to a three-tiered model with a browser-based front end. And most of these applications were dealing with data having small or modest size that fit well into a relational table model, kind of big spreadsheets with related columns. And the applications that were being built didn't have a huge degree of variety, commerce, lookup, etc. So what else was happening then? First, we had the rise of the Google search engine, which provided really powerful access to unstructured text. And the amount of web content was increasing dramatically. So the first Google index in 1998 hit 26 million pages. 10 years later, in 2008, they hit 1 trillion pages, growing by several billion pages a day. That's pretty big data. And the variety of kinds of content has actually grown dramatically as well. You know, emails we've had for a long time, but we've got tweets, Facebook posts, blog posts, comments in Amazon, geolocated photos, POIs, sensor data, and lots of other stuff, hence the term big data. And so in my estimation, what happens is kind of what always happens. Whenever a new information source becomes available, someone takes a look at it and says, wow, it'd be really interesting if we could look at this thing and this other thing, like tweets coming from people in our customer database. You know, maybe we could predict customer satisfaction that way. And so companies began to build new kinds of applications. And I contend these were really information applications. And there are sort of two interesting things, well, probably more than that, but at least two interesting things about these information applications. Most of these applications didn't use data that fell neatly into rows and columns, or at least exclusively. And companies found that lots of the data they wanted to use came from in-house sources, as well as out-of-house. And usually they came from systems that were maintained by different departments and that couldn't talk to each other. And this is kind of where MarkLogic comes in. MarkLogic is a NoSQL database. We call it an Enterprise NoSQL database that makes it easy to build information applications that blend structured and unstructured data. Let me pause and say that again. MarkLogic lets you create applications that can use unstructured data semi-structured information like XML, JSON, things in emails, Word documents, and fully structured relational data in a single application. So I'll talk a little bit more about how MarkLogic works in a minute, but first let me talk about some examples of customers who are building these kinds of applications and how they use these applications to achieve their business goals. So first, this is kind of an unsexy example, the Fairfax County Land Management Team. It's unsexy, but on the other hand, as it turns out, there are like thousands of opportunities that sort of look like this. So Fairfax County, they were struggling to fulfill requests from their constituents about land management issues, property history information, things like parcel history, survey dimensions, liens, dispositions, stuff you'd be interested in if you were buying a house. And when a request came in, the clerk would first need to search a couple of different Oracle-based systems that had been stood up in the past few years. Now, the Oracle systems were supposed to replace an old mainframe system, but after 3 years of effort, the county had given up on trying to port all of the historical data to the new systems. So he'd first have to go to the IT department and get help in finding and extracting the information that was still in the old mainframe systems. And then he'd have to go through like a 30,000 item document store to find relevant PDF, Word, or CAD files. And then he'd actually have to search through a filing cabinet and see if there were any relevant hard copy as well, and then compile all this information together and put it in a form that that he could use to deliver it to the person who was requesting it. And so this process, as you could imagine, took days or sometimes weeks. So Fairfax built a land data repository based on MarkLogic, and the repository has an easy-to-use search engine, which they use to bring up property history or other information associated with parcels. As an example, typing in the word heliport quickly brings up data on all the heliports in Fairfax, as well as any information like permits, which is associated with it. And the data can be presented spatially, by a GIS such as Esri, as well as in text form. And so this particular example, as you can see, highlights some of our strengths: aggregating disparate data types from mainframe, from Oracle, from regular documents, fast, robust search. And in contrast to their failed Oracle implementation, the first phase of consolidating the county's data was completed in 2 months. Second example, big investment bank. An unnamed but very well-known Tier 1 bank, rhymes with, no, had an issue with its research department. So they weren't able to publish research as quickly as they needed to, and as a result, they were losing market share. Since the earliest available equity reports tend to be the ones that are most read, the bank wanted to streamline the authoring of their reports. And with their current system, not only was report creation too slow, but adding features to the system took too long. So adding new features like mobile delivery was seen as this huge undertaking. So for this customer, we actually competed against incumbent technologies from Oracle and FAST. It's nice to beat those guys. There were 3 compelling reasons why customers decided to move forward with MarkLogic. 1, fast development. They wanted to move from a 6 to 12-month feature development cycle to 3 to 4 weeks, and we allowed them to do that. Time to market. They wanted to reduce the time it took to author research reports so they could become the first research organization to publish a report on a particular topic to their syndication partners. And 3, they wanted to increase their research quality. So to improve report quality, the analysts needed to know what had been previously written on a particular topic before authoring a new report, and so they needed to be able to quickly search existing research. And in this case, there was actually a lot of resistance to MarkLogic because of the investment in their existing technologies. In this case, as in the one I just mentioned, we delivered a proof of concept that had pretty compelling functionality in it, and we were able to convince them that our platform would be able to grow with them and, to help address future application and business needs. The FAA is actually a pretty interesting use case. It's a real-time situational awareness system. So MarkLogic is using, the FAA is using MarkLogic as the backbone of what they call their Emergency Operations Network, EON. And this program is used to monitor and track emergencies and severe weather. It has a dashboard that's updated in real time for crisis management, and it brings together and stores information, common theme, from a variety of different sources. Some are in-house, some are live, like social media, tweets, weather reports, and you know, as turns out to also be a common theme, they had failed in their attempt to build the system on Oracle. And so as an example, you know, if a hurricane is bearing down on Florida, EON users could find out while it's coming ashore which airports in southern Florida have fuel and exactly how much fuel. And something like this is invaluable for emergency responders trying to perform helicopter rescues, for example. Pictures displayed on a web browser with search and geospatial searching, has alerting and analytics as well. And MarkLogic is the repository for all this information. And it also brings together third-party content, as I mentioned, the tweets. It integrates with third-party products like Google Earth, SharePoint, and the FAA's internal systems, such as GEMS and Skywatch, which are actually Oracle-based products. In this case, our proof of concept was built in 2 weeks, and the FAA said our proof of concept actually provided features they had been trying to do for about a year. The entire system went from purchase to beta in about 6 months. The BBC, okay, this is a recent example. The BBC has actually used MarkLogic for a number of years, but they had the Olympics, and they had a big challenge with the Olympics because they wanted to move their site from what was essentially a static, individually curated site to a dynamic one. But it was kind of a dynamic site with a twist. They wanted viewers to be able to track results by team, by country, by sport, by athlete. And so they had these dynamic page templates for each of these. And all that info, all the particular info was displayed, as well as they had a sidebar filled with related info. And all this information was stored in and delivered by MarkLogic. And the interesting thing was this application could theoretically have been served by a relational database. In fact, we talked about that. But the complexity of the data architecture and data modeling would have actually required many, many more months of planning and execution. The site performance was, you know, met and exceeded actually BBC's expectations. They had hundreds of millions of website views. Their traffic was an all-time high. Their requests per week, I mean, it basically broke records at the BBC, which was pretty cool. And the other thing, I'm not sure if I should mention this, but it's kind of a sideline. As Eric mentioned, I've only been with the company for 6 months, and they did something I've never actually seen a customer of an enterprise software company do before, which was 3 weeks before the Olympics was scheduled to start, they upgraded their MarkLogic server. They did a major version upgrade, which, you know, seems like a fairly risky thing to do. In this case, everything worked perfectly, and they were pleased as punch, as were we. So let me talk a little bit about the internals of MarkLogic, how it works, and I'll, you know, just gloss over this at a fairly high level. So I mentioned earlier that MarkLogic was conceived of and created at a time when there were these 3 major trends going on: a change in relational databases from client-server to browser-based client, rise of search engines like Google, and this explosion of information both from the web and from these other data sources. And so MarkLogic was designed in some sense to build a bridge between these models. And it kind of says, hey, a Google search is really a kind of query. It just doesn't really return much structure. And a SQL select, that's really a flavor of a search, but it only returns a limited, very structured result. How could we put those together and make a more powerful tool And by the way, build it in a way that makes it incredibly scalable so that it can handle the largest data sets. And the goal, as you've seen from the customer case studies, was to create a tool that allowed people to access and use, 1, structured data from relational sources, 2, full text from unstructured sources, 3, semi-structured data from XML, JSON, Microsoft Office docs, emails, tweets. These are semi-structured as well. And in the case of these kinds of data, both the structured and the unstructured info is important. So in an email, you want to know the subject and the to, who it's from, as well as being able to scan the body of the email and get information from that as well. So fundamental to MarkLogic is the concept of the universal index. So the universal index indexes all the words, but it also indexes all the structure in your data sources. So you can use it to answer questions like, from this large body of emails, find those sent by this particular user, sort them in reverse chronological order, and locate the last email they sent with a footer that had a phone number in it. Return the phone number. The system automatically, it's NoSQL, so the system automatically determines how to index the data as it's loaded into the database. You don't have to do this complicated data modeling. So you need no a priori knowledge of data structure. There's no need for upfront data modeling. Adding new data elements or changing data elements isn't disruptive, and searching millions of records still has sub-second response time. And we also have this concept called a range index, which allows a developer to easily create what we call facets for faceted search. That's, if you do a search in like Newegg or something like that, on the left-hand sidebar, you'll see entries that let you drill into particular aspects of your result set. Or in the latest version of MarkLogic, you can use range indices to make MarkLogic appear as if it were a relational data source to external tools like business intelligence programs that communicate through an ODBC driver. I've mentioned a lot, some of MarkLogic's search capabilities. It has, comprehensive full text query capabilities, and we're actually replacing fast search in a bunch of accounts, and in particular those fast on Unix is being deprecated by Microsoft. We have tunable relevance ranking, a lot of text-related capabilities like stemming, proximity boosting. You can hook it up to entity enrichment tools. We support over 200 languages, and we actually have robust geospatial capabilities that allow you to mix both geospatial and text searches. In the latest version of MarkLogic, we've done something I actually think is pretty hot. We are the only document-oriented NoSQL database that can actually be used by popular business intelligence tools like Cognos and Tableau. So we actually use these range indexes, which I just mentioned, to make ODBC data sources look at MarkLogic as if it were sort of a relational data store. And what this allows people to do, customers to do, is to get the benefits of BI, things like data analysis, visualization, reporting, but it's on top of a real-time operational data store. So business analysts now can use the tools they're familiar with to understand and analyze MarkLogic-based applications. As I mentioned, we're a real-time data store, so BI queries against us will always give you up-to-date results. So you can, take action on those results immediately. And we also actually have a lot of capabilities that are not available in traditional relational data stores, which we're beginning to expose through extended SQL keywords and other mechanisms. We love unstructured data, so you can leverage this full text search as part of your ODBC query, unlike relational data stores or enterprise data warehouses. We've also, especially in the latest version of MarkLogic, MarkLogic 6, we've made it easy to create pretty powerful analytic applications by including a set of interactive visualization widgets that ship with the program. These are all sort of wired together, so as you click on one, you can refine your query and search results. We have an application builder tool that makes it very quick and easy to build application prototypes that build search and visualizations. We also have UDFs, user-defined functions, we call in-database MapReduce, that allow you to take advantage of our parallel processing engine to perform statistical type analyses. Finally, and I think maybe most importantly, we're not just a NoSQL database. We're an enterprise NoSQL database, which means we have the hardening and security features like ACID transactions, which will basically ensure that a transaction isn't committed until it's completely finished and that all clients have a consistent view of the database. Things like replication, journaling, allowing you to do point-in-time recovery, and the hardening features that are standard with enterprise relational databases, but actually don't really exist outside of MarkLogic for most NoSQL databases. But these are the capabilities that customers depend on, rely on, if they're actually going to run their business on this system. So I've given you a taste of the many, really hundreds of different use cases and applications our customers have built on MarkLogic. In conclusion, we're a NoSQL database designed to build the next generation of information applications. And these are applications, as I mentioned, that combine structured, semi-structured, and unstructured information from virtually any data source. We combine the best qualities of a search engine and document-centric data store with enterprise-grade reliability, and we've been used for a real wide variety of applications in publishing, financial services, government, healthcare, and other fields. We've been around for 11 years, and we were designed from the ground up to be sort of an enterprise quality system. So there are a lot of NoSQL applications, databases that have come out in the past few years, and for the most part, those systems lack the enterprise qualities that customers, companies need to run their businesses on. Thanks, and that kind of does it for the formal part of my presentation.
Okay, and let's see, I'm going to take over the keys here and move the slides for Neil. And folks, as many of you know who are veterans of attending the briefing room, the Q&A is the best part of the show. So send us in some good questions. We have a good number of excellent questions already in the queue. And with that, I'm going to hand it over to Neil Raden of Hired Brains. The floor is yours.
Okay, thanks, Eric. Well, the first thing I'd say is that the 30 or so year reign of relational databases is really getting challenged by this NoSQL movement. It's happened before. I remember when object-oriented databases attempted to displace relational, but it didn't work. But this time it's serious. So the question is are NoSQL databases going to be the replacement for relational databases, or are they going to be a complement to it? Interestingly, lots of NoSQL tools predate this big data rush. And MarkLogic is certainly one of them. It's almost as if they anticipated the big data movement. They manage all sorts of data, including what we call unstructured data, although as far as I'm concerned, there's very little data that is truly unstructured, but that's a conversation for another day. But it's sort of remarkable, in addition to all the database things they do, that they can interpret text in numerous languages. I know they said 200 languages, but I believe their core language set for really doing hardcore text analysis is about 20, which is pretty good. And they can scale massive volumes, obviously. So in general, what needs to be addressed by NoSQL? I'd say the first thing is cost, and that's a major one. Licenses for databases are often open source, but not always, and that's certainly the case with MarkLogic, but when you expand to 100 or 1,000 or 5,000 servers, to buy an actual database license for each of those servers would really break the bank. So one of the motivations is these open source database languages that make that less expensive. Secondly, is the scale on commodity platforms, which is also important because, well, in the case of MarkLogic, you've got a distributed document-centric storage and database system, and you want to be able to scale that. And I think they're very well suited to cloud placement. In fact, they're extremely well suited to cloud placement, whether it's public or private. And I think that the no schema concept that Steve mentioned is also very important. The idea that you don't have to go in excruciating detail in terms of designing a schema before you can load any data in it, and then it becomes like poured concrete. You know, it's liquid when you pour it, but it eventually gets hard. You have to jackhammer it up if you want to make any changes to it. And because of that, you don't have to convert your input data to a fixed schema or reconstruct your output from the tabular stuff to the kind of presentation you want. And of course, the last thing is speed. Now, in fairness, relational databases can provide exceptional speed as well, and especially when loading data in bulk, provided it's in the correct form, which really is a drawback when mining big data. Now, also, the relational databases that are built specifically for analytical work can perform extremely complex operations, including advanced quantitative functions. So, like everything else, you know, there are shades of gray. So, next slide, please.
Oh. Go ahead.
There's a misapplied belief, I think, that gobs of data can be ingested by a room full of computers and all sorts of great insight can be derived from it. It isn't true. Because we've always designed systems to be stingy with the way we store data. Remember Y2K? Remember how we just did everything we could to just get 2 characters off of a record? Data is usually stripped of all of its meaning and relationships when it's stored. So you simply can't read it from its storage mechanism and understand what it means. So if the information is available at all about what the data means, it's usually buried in the program logic that owns the data. As far as I'm concerned, don't look to metadata because it usually isn't enough. So with this raft of new data sources today, the problem is even more severe. So I'd caution you to rein in your expectations about big data and really cast a jaundiced eye to anyone telling you they can ingest all of this data and then provide you with a new world of capabilities. We learned some really hard lessons in data warehousing, particularly about data integration and data quality. All of those rules still apply. And also, like I like to say, data never speaks for itself, but it aligns itself with a model, either one you already believe or maybe a new one that you want to test. But data is not like an oyster exuding pearls. It really doesn't work that way. And you can't change the fundamental laws of physics. You can't take data from a bunch of disparate sources without any semantics about it, put it together and understand it and have good analysis on it. It still takes a lot of work. So in the case of a document-oriented system, you may be able to find the 10 counterparties to a securities transaction in real time, which is important. The question is, can you analyze those transactions over time and rank them with something like a likelihood estimate for risk analysis? So that's a question I definitely want to get to Steve. Next slide, please.
Okay.
Okay, so Willie Sutton, you know, maybe I'm showing my age here, but he was a famous bank robber, and he used to get caught on a fairly regular basis. And when he was asked why he robbed banks, he gave the simple answer, because that's where the money is. Now, this begs an interesting question if you ask me. Why stop it being a relational database? I think you'll see this as really a convergence question about how these technologies are converging. After all, the purpose of the data warehouse is not to lock data in a box. It's supposed to be part of a process that helps organizations understand their business, make some predictions about the future, and who knows, maybe even make some good decisions, or at least inform them. So the question is, why not widen the database to include all sorts of databases, relational and non-relational? So take a clue from Willie here. Why invent a database that can handle the usual jobs and everything else? Simple. Because that's where the data is. So lots of NoSQL databases are claiming they can do just that. Now, I'm not sure exactly where MarkLogic is on this issue, and we're going to ask Steve about it in a minute. Next slide, please. But with all the cool stuff going on, don't forget we still have to count the beans. All of the reporting and informational requirements we had 5 years ago are still with us. Regulatory and statutory reporting, external and management reporting, it doesn't go away with big data, right? So if we're looking at these tools like MarkLogic, we have to ask that question. Are they replacing our relational database, or are they a complement to them? Can they still do these unglamorous things that we worked so hard to be able to do relatively well over the last 10 or 15 years? Now I've got some questions for Steve. Shall I just go right to them, Eric?
Yep, just go ahead and dive in.
Okay. So Steve, here's my first question. Who is Mark?
So in this case, Mark is sort of short for markup, and that's actually there actually is a Mark who took credit for this. It was Mark Kavami, I think, who was one of the VCs who helped bankroll MarkLogic. But it really sort of is short for markup, which is sort of stands for XML.
Okay. All right. So it was an answer to that question. All right. So here's a real question for you.
All right.
Why would a customer choose MarkLogic over Hadoop?
Well, you're kind of talking about apples and oranges in some sense. So Hadoop is a batch-oriented system that's actually used, from my experience, most often for ETL or ETL-like activities. So you want to take a bunch of data and refine it, calculate results, and then return that. So we actually work quite nicely with Hadoop. We have a Hadoop connector that allows you to basically move data that you want to analyze using Hadoop out of MarkLogic into Hadoop and back very easily. So we have a use case, a scenario for data refinement. For example, maybe you have video or photos, and you want to use Hadoop to do object recognition within those photos. You have MarkLogic send those to Hadoop and then send the metadata or information about what's in the photos back through the connector to MarkLogic. And we're also actually doing some interesting things that in the future that will blend use of the Hadoop HDFS, the Hadoop file system, with as a storage medium with our own MarkLogic storage.
Okay. All right. Well, but Hadoop, you're really talking about the base level functionality of Hadoop. It's piled on a bunch of other things too. So if I wanted to do, machine learning, I'd have Mahalo or all those other things. Do you see an overlap there? I mean, one thing obviously with Hadoop, there is the cost issue, correct?
What cost issue are you referring to?
Well, MarkLogic is enterprise software, and I did notice in one, and I'm not pulling these numbers out of the air, I did notice in one of your case studies that the license fee and the consulting fee to get a project up and running was somewhere in excess of $1 million. And if we
start at cheaper price points, by the way.
Okay. All right. Well, let's not beat that dead horse. But
yeah.
Let me just go on to a different question. How does all of this mixed media data get transformed into XML into your ingestion process?
All right. This is Jason. It's my turn to start talking. I can also address the last question if you want me to go back to that one too.
Sure, why not?
I'll start with mixed media, then we'll go back to Hadoop.
Okay.
Mixed media, it depends on what the data is that you need to represent. It's sort of a two-pronged process with mixed media. You need to store the binary, and you need to store the metadata about the binary.
Right.
And so to store the binary, we've created optimized representations, which makes it cheap to store very large binaries, cheap to serve large binaries. And with HDFS, it's actually a good way for us to, it provides a good tech base for us to do even more with large binaries that we're looking at. Then the metadata part, MarkLogic works really well for metadata because of its flexible data model. The challenge of metadata in a rigid relational form is you have to know everything you might ever need to know up front when you're modeling, or expect to make a lot of changes over time, which can be painful. And so using an XML data model, like MarkLogic does for metadata modeling, works really well. The multilingual capabilities works well if you need to have, for example, titles of things in different languages. The geospatial works really well for things that are metadata about something like satellite imagery. So if you picture you're going to track satellite images coming down live streamed, you need to store the images, sure, but you also need to store when it was taken, what it was taken of, the altitude, the azimuth, the cloud cover, the geo points that are represented within it, the polygon probably that it can see, whether it's night or daytime. There's a ton of metadata that you need to do, as well as user, analyst notes that might be free text about it. So we'll store the binary and we'll store all that metadata and make it searchable so you can find exactly the very latest image of whatever it is you need. And that works for congressional transcripts where we power Congressional Quarterly. It works for things like intelligence agencies tracking movies. It works on tracking terrorists with pictures of terrorist activities. So that's the key thing is there's the binary and there's the metadata. We partner with people to do the metadata extraction. There's so much you can do about a picture. You can identify kinds of flowers. You can identify people's faces. There's just too much there. So we say, whatever it is that you need to do as a recognition, we'll partner with them. They just give us the knowledge that we encode into the XML metadata. Jumping back on Hadoop and then, does that answer this question well enough?
Yeah, I have some follow-up questions that I think that are kind of.
All right, let's do that first, then we'll jump back.
Well, I guess the question I have then is, you say you give that to someone else to handle. I've read a lot about MarkLogic being operating in real time, and that brought up a couple questions for me. The first was, it seems like when something comes in, it comes into memory in some sort of a tree structure, and then when that piece of memory or chunk of memory gets full, it gets flushed out the disk. That doesn't sound real time. Yeah, I did. That doesn't sound real time. That sounds sort of like, I don't know, we had a word for that. We tried that in data warehousing too.
You're assuming you can't query what's in memory though, and what is in memory is always queryable. So it goes into an in-memory data structure. It also gets journaled for resiliency in case of failure of the machine. But the query crosses all the things that have previously been written on disk as well as what is now in memory. So the moment that it has been committed, it's in an in-memory data structure ready for live query. Then why do we buffer it up? Because spinning disks are really bad at random writes. So if you can buffer 64, 128 megabytes of what we call a stand in memory, then we can do a sequential write, which minimizes the disk crashing.
Right. Okay, all right. I misunderstood that. I thought it wasn't queryable until it hit the disk.
Absolutely.
Okay, so when I want to go out and find the counterparties to securities transactions, because that information is indexed, I can find that very quickly, and I can return the documents very quickly, hence the speed of operation. I get that. But considering what you have to do to ingest data, what's the speed of ingest like compared to the speed of query?
Well, it's interesting. The units are different on ingest and query, right? Because ingest is megabytes per second, typically megabytes per second per core, and query is more about queries per second. I wish there was an actual workload query that you could do because some queries are light and some are heavy. MarkLogic emphasizes being able to do constant queries while doing constant load. And we work very hard so that our load can be proportional to the amount of hardware that you put into the load so that we can scale out horizontally efficiently. And it was years ago about 1.5 megabytes per second per core, and I think it's kind of stayed there as our indexes get a little bit deeper and as hardware gets faster. So we've always done it so that it's very fast. The amount of data that you can ingest, we've figured we could handle all of Twitter, for example, in a cluster, not a problem. All the constant traffic that's going on there. We have customers that are loading good portions of the internet, updating it constantly while doing live queries. So ingest has been very fast. And then queries, a whole other aspect of that. But if you can do intelligent index-driven queries, then you can get real-time access to this ad hoc data. And I think that's really MarkLogic's value, is we've figured out how to do ad hoc queries against ad hoc structured data. So you don't have to box yourself into a certain data model or a certain query that you're going to ask. You get to pick both constantly as your app evolves, which makes your app cheaper and yet remaining performant.
Well, the mystery about how all that works escapes me, but I'm going to have to dig into that later. But in terms of these ingest speeds, you're talking about, bytes or megabytes per second per core. But you also have to do processing on this stuff. It's not just writing bytes to disk, right?
But that is the processing speed.
Okay. All right. Okay. Good. So let me go on to the next question then. We hear a lot about big data. Actually, too much lately. But despite the fact that much of the data is not traditional structured data, a lot of the analytics eventually are going to resemble the quantitative analytics that preceded it, right? And because MarkLogic positions itself as a big data player, how does it support these deep quantitative analytics of big data? I read a case study, and I really did read this stuff. I read a case study that mentioned MarkLogic provided scores and data visualization for the London Olympics. How did that work?
How did that work? From what I hear, I wasn't the one coding it. From what I hear, they've fed all the data into a singular MarkLogic system. So we were the master repository of all the stats, down to in a soccer game, who was kicking to where. And because the amount of data that you get from all the different sports is really varied, MarkLogic worked very, very well for it because you just had the model, the data model for each one, yet you could do it all in a single database that could be centrally queried. And then you could take that data and feed it out to articles, feed it out to the TV. I'm told a humorous story. They had to slow it down a little bit. MarkLogic processed it so fast that it could put on the TV the actions before the actual thing happened on the video. So like, goal! And then you see it go in. Like, okay, maybe we need to slow down MarkLogic. Its ingest rate is a little too fast here. But you also get to put the articles into it, right? So the articles, the data that's feeding the articles, and all that kind of metadata goes into one place. And for them, it just became, that's where stuff goes, right? And if we need some statistics, et cetera, we get it there. Is it deep quantitative? I don't know. I could sum up how many goals everybody scored. That's trivial. I mean, that's not deep. We aren't doing predictive analytics of who's going to win the next game on that one. But what it provided was a centralized heterogeneous repository.
Yeah, and one thing that's important to note is that, we know if a stored value is a number. If we know it's a number, we can do things with it. We can aggregate different numbers. We can perform calculations on them. And in fact, in the latest version, we've added, I think I mentioned, user-defined functions, which take advantage of our parallel processing engine. So you can do actually fairly sophisticated analytics, and you can write them in C++ so they operate really, really fast.
Okay. Well, let me get to the question I posed in one of my slides. Is MarkLogic a replacement for the analytical databases, or is it a complement to them?
I have to sort of go back to some elements of my presentation. I think that MarkLogic is really oriented towards building these new kinds of applications that are starting to become kind of mission critical, that blend information from many different sources. If you look at the spectrum of NoSQL technologies, there's like key value stores, column-oriented data stores, document-oriented data stores. And in my opinion, a lot of the energy that's going into the column-oriented data stores and even the key value stores is how can we do relational stuff in a more scalable way and faster. And that's not our mission at all. Our mission is to, is not to do transactions faster or allow people to build more effective shopping carts. It's really to blend different kinds of information so that you can get new and different kinds of insights.
I would disagree with one thing you said. I don't think that the analytical databases way to do relational stuff faster. That isn't true. They're a way to do continuous analytics faster in a sort of relational database. So they have time series analysis, they have geospatial, they have the ability to write functions that can reach out to and execute MapReduce, and they have embedded quantitative methods, analytics, optimization models, and so forth that have all been burned into their core. So that's why I'm asking, the relational databases aren't like old dinosaurs sitting there standing still, right? They've innovated too. Right. And I'm just trying to get a sense, because I see a diagram here that came off your website that says enterprise data layer. It has semantic model and so forth, presumably being MarkLogic, that it seems to position MarkLogic at the center of all the information needs of the organization. And I'm just wondering, if that's the case, what other objects are needed out there, in orbit to make all the things happen that need to happen.
Right. The way I think about it, if we think about the FAA use case, and I picture what would the FAA do with an analytical-oriented database, I think after the fact they could analyze how many people got messed over by that weather event, how many people are being inconvenienced by hardware, operations issues. I don't see it being used to actually get people home faster, right?
Well, I don't agree with that. I think
you think you would do that? That you would load up the capabilities of planes, you need to figure out a plane where it should land, if it's running low on fuel, how to reroute, making decisions about that. That kind of stuff seems very tricky to do in an ad hoc live way where I just need to get a real answer and I'm inventing the query right now so that I can solve a problem. Yeah. And that works very well with MarkLogic, where sometimes it's do a numeric analysis. Sometimes it's a search, right? Sometimes it's just a free text search you have to do. And I've not seen a lot of analytical databases that are deep on the full text search give me relevant things.
No.
So the ability to mix between a database style query, a search style query, an analytical style query is where the power comes from, by taking in lots of different data feeds. You can take in weather, you can take in information about airports, you can take in live feeds about passenger manifests, whatever it is you need to pull together, and then ask questions about that. And that's where we aim. I would say, they'll probably shoot me here, but we aim for the lower end of the analytics, not the PhD in math analytics kind of stuff. You solve the...
All right. I'm getting the hook here, so I have to put this question back at you, though.
Okay.
And that is, are you suggesting that MarkLogic has the primitives to do what's the best way to optimize our flights?
That's actually the very interesting question. One is, optimize our flights. You know what? Tell me next week. Next week is fine about that, right? Mm-hmm. Whatever. How about right now things are going bad. What do we do right this second, right? Yeah. MarkLogic emphasizes the I need to know now. And you didn't include the one, but like oil trading, right? I need to make a trade right now. What do I know? Right? I got seconds at most to make my decision. I need a fast query engine that has already loaded a bunch of data. If I get a new feed, I got to start querying that right away. I don't have the luxury of a MapReduce job that's going to take a week to figure out. That's like a traveling salesman problem, right? It's an NP-complete, just exhaustively go through everything to figure it out. We want some sort of index-driven find me now. I need to know, what's the next possible way to get this person to there. I need to know if this hurricane goes through this geopath, which flights are going to be impacted. Questions like that, and I need to know fast. So we emphasize.
Well, we need to leave some time for the audience questions, but I'm just going to leave you with the fact that I actually don't agree with you when you talk about this so much.
Oh, we're going to arm wrestle.
Hey, those are some good questions. We got a lot of good questions from the audience here too, and I've been really thinking about this stuff as you guys are discussing it. It's some very interesting stuff, and there's a question from the audience: is this product appropriate for an analytical data warehouse? And I guess what I hear you saying is that it's very useful for real-time type questions. So I guess what I'm wondering is, I'll expand on that question and ask, have you seen use cases where there is a bridge created between the enterprise data warehouse and the MarkLogic database, and you get some sort of a hybrid or synthesized view of information in sort of a control panel or something? Does that make sense?
Yeah, I wish I saw every customer deployment to know what they do with us. I see some customers like CMS, we can talk about CMS, Center for Medicare and Medicaid Services, which is having to unify together data from every state. And of course, every state has agreed on a strict schema of how data should be represented, and they fully conform to it. No, wait, that's not it. Everyone does things differently. And so they have to bring it together in one place and still create a health information, this insurance exchange system. And so MarkLogic works well with handling the varied schemas. Now, for them, we added the Cognos layer so that they could still do BI against that. The point wasn't, hey, I need a way to do Cognos. The point was, we need to unify this data that's really crazy. But by providing a Cognos interface, by exposing this unstructured data as if it were SQL so that Cognos could understand it, they got to do things the way they had done it before. It wasn't the reason they bought MarkLogic, but it was a nice benefit to using MarkLogic that they could still do things that way. Now, what they bought us for is to drive the insurance exchange and answer the deeper questions about assigning, going in and finding the right insurance for yourself.
Okay, good. And I'm going to push this architectural slide again as we go through some of these other questions. So one of the attendees asks, can MarkLogic be accessed to perform predictive analysis with tools like SPSS?
Yes, we can export data formats that they chew over. It's not the core value of our product.
Okay, good. And here's an interesting question. One of the attendees asks, can we classify MarkLogic as a type of data integration engine?
For some people, that is what they do.
Interesting.
And that's where you see the EDL, the Enterprise Data Layer discussion. We see that mostly in governments where I think for bureaucratic reasons, they have the pain more acutely than companies where a CEO could mandate things.
Interesting.
Yeah, we also see that MarkLogic deployed in lots of situations where you have departmental data stores that are all configured differently, and you need to bring all that data together. Warner Brothers, for example, is using MarkLogic to integrate a whole bunch of metadata from all their film stills and TV assets, so that someone can search across the entire corpus of their stuff.
Okay, good. And we've got a question around metadata, and I'm glad when attendees ask questions that I wanted to ask. One of the questions is, how does your application extract or determine the metadata values that are required with all the data, i.e. for that satellite download example you used and the metadata related to that?
Right. Short answer is not our problem. Our job is to take the metadata and make it highly queryable. So that, for example, the National Archives and Records Administration is a customer of ours tracking the metadata for all the assets of the government for the lifetime of the Republic. And it's not our job to look at a sword and figure out the aspects of that sword that should be tracked in the metadata system. It's not our job to look at a satellite image and decide what attributes of that satellite image should be tracked. It's our job to when you've decided what that should be, no matter how complex and how messy and how detailed, and no matter if it involves free text or numerical values or string values or geospatial values or whatever, to be able to store that reliably for the lifetime of the Republic and give you deep retrieval capabilities based on that without having to do a whole lot of upfront indexing. And to the extent you want to do analytics to say, so what's the most relevant to this query kind of weapon do we have? How many weapons do we have? What kind of paper do we have? Who is the most common author of the papers that are managed by the National Archives? Whatever the kind of question is like that, to be able to do that quickly. But if we're doing the Congressional Quarterly like we do, it's not our job to do a transcript of Congress. Someone else does that. We associate the metadata with the video feed. So if you do a search and you say, I want a Republican from the South saying the word taxes, we can tell you exactly when it happened, how often, give you a chart of it over time, and pull up the video feed associated with it.
That's very interesting. Okay, good. We have another good question here. One of the attendees asked, do you use SQL at some time, for example, for the translation of natural language queries or upon facets, or are Cognos and Tableau required for something like that?
So what we did is in the new MarkLogic 6 release, we added a SQL interface where you can say these parts of a document should be considered columns. And then you can do a read-only SQL query. We don't do write, but a read-only SQL against that. And the main purpose of that was to support BI tools and to integrate with workflows that people already had where they wanted something like that. Now you can still query outside of SQL to get deeper understanding of the unstructured nature of your data. But a lot of times you're able to sort of say, all right, this element and that element and this other element should all be treated the same, even though they come from different data sources. Unify those into one sort of pseudo column, and you still get the real-time aspects of it. So that's the purpose of the SQL interface, is to just provide an easier way for people who already have that tooling.
Right. Okay, and can we talk for a minute about, and thank you so much for giving such detailed answers. That is exactly what we want and what the audience craves in these things. So let's talk about in the architecture here, in the evaluation layer. Can you talk about what each of these different pieces does? So start with the evaluator, then the query cache, and then broadcaster aggregator.
Can you? I'm trying to make it bigger. It was about 1 point font. All right. So what's important to understand here? One is that, let's start at the bottom. At the bottom, we store the data, right? It's a transactional repository. You can make any number of updates. We'll treat them as an ACID update, right? That's a differentiator. It's one of the reasons that we're enterprise. That works for XML, JSON, binaries, text as well. We index that. That's the layer up above. You see kind of value indexes, which is very much like a relational database. Structure, though, we understand the hierarchical nature of these data formats. Lots of text indexes, multilingual support. We represent full Unicode. We understand different languages. We can collate and stem all these different languages. So really rich text. We have a strong search engine background here. Scalars, just for things like sorting, metadata, XPath. Security is baked into the indexes. That makes it much faster than if it was done after the fact. And so that means that every person who interacts with a database can see a different view of the data based on their security credentials, geospatial, and even reverse. Reverse is a way to not index documents, but to index queries so that you can match. As documents are loaded, you can say, hey, this document's new, and it matches that saved query. It's a way for customers to express an interest in something and be alerted the moment something happens. We see Congressional Quarterly doing that. So if you say, I want to know when a Republican from the South says the word taxes, we'll tell you a millisecond after it happens. That's using the reverse index. Above that, you have a cache, of course. You have journals. That keeps your data safe in the event of node failure. And a transaction controller, we use MVCC, multi-version concurrency control, as a technique to ensure transactions. In a cluster, we use two-phase commit to keep things synchronized. We even support XA, which is a standard to do transactions across systems. So you can do an update to us and Oracle as part of the same transaction. We'll participate as an XA client. The whole screen just went away.
Yeah, I know. I'm bringing something up here.
And above that is vaporware and does not exist.
I wanted to do a share of my desktop here because I'm looking at your site and at your partners, and we can close out on this question. I think this is absolutely fascinating, folks. So if you look at these partners, what I notice, with the exception of Connotate, for example, these are very interesting partners. This is not the usual group of partners that you will see in a technology company's website. Can one of you guys just kind of talk about the partner program and who you look to partner with and what you get from your partners?
All right. There's different aspects, right? There's the technical partners, which is the page you're on. For the most part, what you see here is when I said not our problem, sometimes that means it's these people's problem. We partner with people who want that problem, right? And so if you look here, you see people who are doing like DCL does data conversion. We have a customer that says, gosh, I'd really love to have my data in a decent semantic markup, but all I've got is this pile of PDFs over the years. What could you do about that? You call up DCL, and that's their domain. They fix that. Antenna House for conversion of document formats, things like that. Temis, right, for things like entity extraction. So there's a whole ecosystem that we encourage and have created of, managing data as it comes in and transforming it so that it can be more queryable, right? If I have video feeds, if I have images, if I have whatever it is, plain text needing to get some text analytics against it. On the other side, also sometimes visualization tools. I need to be able to better visualize something on the other side. We maintain our focus on making an extremely fast, enterprise-grade system that can do really deep queries, really interesting analytics in real time against a wide variety of data. And we try hard not to be too distracted by things like an NLP system, because that's something that a lot of people out there are doing, and why not partner with them. In fact, for a lot of people, what they like is, we want to deal once because the competitor said they'd do it all. And the customer said, yeah, but you're not the best at it all. And these people are better at geotag identification, and these people are better at text analytics, and these people do Arabic name disambiguation, which we really care about, and you don't even do that. So we won the business because we turn, as our founder said, we turn semantics into structure. So you just mark up your data. If you figure out that something is a weapon, you put a weapon tag around it. If it's a person, you put a person tag. If it's a place, you put a place tag. And then on that place, you can add attributes of its latitude and longitude. So whatever tool you have out there that can identify places, we'll work with it. If there's a better one next year, we'll work with it too. Its job is to give us better markup. Our job is to be able to query that markup for an effective application, right? And so they enjoyed the flexibility we gave them of it wasn't a closed system where you had to work with our own NLP, you had to work with our entity identification. They could change their mind later as new things came, or mix and match. They did mix and match. You know, the same thing that does geotagging shouldn't do Arabic name disambiguation, shouldn't do weapon identification, shouldn't do chemical signature identification. We've partnered with people who do things like, is this chemical the same as that chemical? And that's a very domain-specific problem. But it works with us because you can create on each chemical that's in your database, you can add an attribute that's its canonical identifier. And now you can do analytics against how often each chemical is mentioned, no matter what its name in the source, things like that.
That is really fascinating stuff. Well, just fantastic job answering questions, guys. We really appreciate that. That's what we want in the briefing room. Folks, you can see the topics coming up. This month, of course, is database. We have several more lined up for you. Next month is cloud, then innovators. In January, right back to that topic that Neil said we talked too much about. A very big thank you to Neil Raden for his time today and for his homework. We love when analysts actually do their homework. Very big thank you to the folks at MarkLogic for stepping into the briefing room. This, I have to say, was really, really good stuff. So thank you so much. And folks, with that, we're going to end our webcast, but we do archive all of these at insideanalysis.com. So feel free to check out the archives there. You can see it really is a who's who of innovation in today's world of information management. But boy, great stuff. Such interesting technology here. And as you can see, folks, from looking at that architecture and from looking at the partner network, realize these guys have been around for 11, 12 years, and they've been busy. They've been doing this stuff for a lot longer than most. So fascinating content today. With that, we will end our call. Speakers, stick around for a quick post-briefing. And thanks again, folks. You've been listening to the briefing room. Take care. Bye-bye.